So in this video, we're going to look at solenoid, the magnetic field from solenoids and toroids, which is in chapter 31-5 and 31-6 of the textbook. All right, so first off, solenoids. Well, a solenoid is really just a whole bunch of current loops all wrapped around together. So that's what you want to think of, a large number of axially aligned current loops. Now the nice thing about a solenoid is that the field inside the solenoid is very nearly uniform, so it's straight along the axis and uniform. The field outside the solenoid is typically quite small. So the right-hand rule gives the field direction. So if you wrap your fingers in the direction of the current, your thumb points in the direction of the magnetic field. So inside the solenoid, so we can actually use Ampere's law. We'll do this in detail in class to see how this works, but we can draw an Amperian loop, calculate the path integral of the field around the loop, and look at the current through the loop. And what you find is that the field inside the solenoid is mu naught n times the current I, where n is the number of turns or the number of loops per unit length. Okay, so toroid, well, basically for a toroid, you take a solenoid and you bend it into a donut shape. So there's a bunch of coils wound around a donut, and the field then is actually around the center of the donut. So, and the field you get, and again, we'll look at this in class in detail how you do this with Ampere's law, but it's going to be mu naught times n times I over 2 pi r, where n is the total number of turns now, and it depends on r. So that's the key difference between a solenoid and a toroid. Solenoid had a constant field inside. The toroid, it's actually changing, so it depends on r. As r gets bigger, the field gets smaller. Now there's actually a interesting application for a toroid, so it's something called magnetic plasma confinement in a tokamak. So a tokamak is a device for doing nuclear fusion, and you have this plasma, which is a very, very hot gas. And well, of course, it's so hot, it tends to melt things it comes into contact with. So one of the ideas then is you actually combine it and you store it with a magnetic field so it doesn't touch the walls of your container. And that actually combines this toroidal field around the donut with a poloidal field to create sort of a helical field inside the toroid, inside the torus, and then it can confine the plasma.